Thanks, Ash, for this great introduction and also for organizing this event. It always takes more time than you anticipate, so I really am happy that you're giving me this platform to talk about. And yeah, it's been quite a long time. I gave a webinar. I think the last one has been back in COVID time, so it feels a little bit funny, but I do think that for this particular topic, a webinar is actually a pretty good outlet, which is why we have planned to do this. So, as Ash has mentioned, the topic I want to talk about today is how to publish drone data fairly. And I said drone data in Svalbard because this is a SIOS-inspired event, so we're focusing. So the focus is always on Svalbard. However, I would say that 95% of what I'm going to present here is applicable for all drone data, and only a small part is actually the Svalbard part. So it's admittedly not the sexiest topic. Drone data management, FAIR data archiving, all of these buzzwords. It's not what we want to do as researchers. We want to go out in the field. I want to fly my drone. I want to collect data. That's what is fun. Post-processing and writing papers is less funny, and then having to deal with data and your due diligence that you should do, that doesn't sound fun at all. However, it's a really, really important part of doing science. The Region Research Council, other research council, and funding agencies throughout the country, and all countries, are more and more demanding and requiring that you do have a data management plan in place, that you do share your data, and that you do make it fairly accessible. And there's very, very good reasons to do so. And we'll dive a little bit into that. And basically, my promise to you is that at the end of this webinar, I will give you an overview and the tools as well to be able to share drone data with a minimal effort in a fair way, hopefully so. Very briefly about myself. I see many familiar names in the chat, so welcome, friends. For those of you who don't know me, my name is Richard. I've been involved with Svalbard since 2012, so it's more than 10 years. I've been flying drones since 2017, so it's been quite a while. And I'm a researcher at NTNU, and as Ash mentioned, I did a secondment in earlier this year, where we looked at a bunch of topics, and the data topic was one of them. In general, I see my mission is to help researchers to take their science airborne. I work with a lot of different people in Svalbard who do their dedicated research, and I try to help them to find applications for drones and to answer questions they might have using drone technology. And the background for that is really that, like drones, it's still a relatively new technology that there is not too many people who are using it or know how to use it. And I'm all about kind of finding these application cases. So I go out, I help people to, fly drone missions, post-processing the data. Also, how do they use their data in research? And kind of data management is actually a part of that as well. So this fits good in my portfolio. I will just spend very, very few minutes talking about like why while using drones is such a benefit, especially in places like Svalbard. Also to give you some vocabulary maybe that you can put in the next publication. The big challenge that we have as researchers in general is, that you go to Svalbard and you take your samples, you take your ground-based measurements, and they have a really good resolution, like you can observe things on a millimeter scale or less. If you want to, however, make your research applicable to a larger area, if you want to scale it up or you want to put it into like a larger context, you need a bigger resolution. And that's typically where satellite-based systems come in. They have, depending on what data you're looking at, resolutions between 10 and 50 meters. And there's obviously a pretty big gap in between these. So if you want to really link and be able to scale up your data and your findings and your concepts, whatever it might be, you need something in between. Often this is aerial photography or aerial images taken by airplanes. They have very, very good resolution, can be 1 meter, sub 1 meter scale. However, these are very expensive and very sparsely available. And one advantage or one possibility that has come up in the last, I want to say 10, 20 years, is the use of drones. Drones give you resolutions on like 10 centimeters per pixel scale. They're readily available. They can cover as large areas as a satellite-based system can, but of course they will cover more than you can do in the ground. Interestingly enough, drones come also in bigger versions, more and more. These are being implemented. They can kind of fill up this in-between gap as well and cover larger areas with a little bit of less resolution, which is typically good enough. So UAVs fill the gap between ground observations and remote observations, and this is kind of called also the observational pyramid. It's something that we at NTNU try to work in quite a lot, and we're always eager to find people who want to participate in this. So very basically, it's the same concept that, we want to combine different systems like satellite-based systems, drone systems, and other systems to cover or to answer bigger questions. So for example, if you look at like algae production in Svalbard, if you look at the satellite picture, you see this. You might detect some areas where you might have a lot of algae production, like some green areas. But if you want to really confirm that, you need some higher resolution. So you go to the fjord, you fly a drone, you get these kinds of images. But then really to confirm what type of algae it is or whatever, you need to go there and kind of have a look and maybe even add like some underwater robotics. And kind of combining all of the technologies into like one researcher tool is what we're about a lot. Anyway, Ash has mentioned that I've been writing a SES chapter that will be published this year. That's correct. I've also written a couple of other SES reports, and one in particular where I've focused a lot about like how's drones being used in Svalbard. And a couple of key findings there is that, like, I would say, can't remember the exact numbers, but like, 90% of all UAV applications today that we have in Svalbard is using very, very simple, like off-the-shelf products, typically like some DJI drone. And you can get a lot of value out of this. And actually, most of the products that we're getting is maps or DEMs. That's a digital elevation model, and orthomosaics, which are like big kind of ortho-normalized pictures. And a lot of these, and this is really the most things that we get. However, what I also found in the same report, or we and my co-authors, is that there's very, very bad data management practices used with these things. So there's a couple of reasons for that. So first of all, there's no really data standards. There's not really too many people who like we don't have any good standard of like what you should publish when you publish your drone data. Then also data is lost due to lack of fair data sharing, which is what we're addressing today. Data is also lost because there's no metadata included. And actually today there's no drone data available in the SIOS data portal at all. That's not true anymore because I think earlier last week we finally managed to submit the first data set. Like, how this works normally in real life is, right, it's like we go out, you fly the drones, you collect your data, and very often that's it even. Sometimes, the project falls through or the data wasn't interesting or you don't even look at it. If you're lucky, you actually do the work and you post-process the data, and then you have the data and you look at the data and then you realize, oh, maybe I'm not going to use that. And the data disappears again. Or what happens is that you get really, really interesting data. You take a couple of the data sets that you collected out and you put it in a publication and you publish that. That would be great. But if you look at these publications, then almost never you find enough information to really understand what's going there. And it's actually kind of bad science practice, right? Because science should always be transparent and reproducible. And if you don't include the necessary information about the drone platform, for example, or how you did the post-processing, it's not really good data. And that's kind of the things that we see today. And even more, what we don't really see is that people actually share the raw data. So there would be like these orthomosaics or digital elevation models, or what you actually should share is actually the raw data. And that's actually, we're missing out on a lot of potential here because in my career already, it happened 3 or 4 times that people have actually asked me, they heard that I flew drone missions in a certain area, and they came back and said like, hey, we're looking at something completely different, but I think your data might cover it. So for example, we were counting reindeers using drone images. So we took like large pictures of large mapping areas of Sassendal. And then a year later, somebody came and said, "Hey, I'm looking at some fluvial changes in the riverbed. Is there any chance that actually the data that you have is actually showing these changes?" And indeed, it did. And then they were able to kind of build a time series. So if we don't follow these drone standards, if we don't share and archive our data, this is kind of lost. So there's a really big untapped potential there that we want to work on. And that's basically what we did is, or what I did here is to develop a process on how to add this drone data on drone-based DM data, which is kind of the simplest and most important data, to the SIOS portal and to make it fairly available. Okay. Of course, this whole data sharing and data archiving concept, it's not something new. It's not something that we or SIOS or anybody came up with. This is around in science for a really long time. And when I talk about FAIR, it doesn't have to mean like, fair isn't just. It's actually an acronym for this. Most of you have probably heard this. FAIR data means that your data should be findable, accessible, interoperable, and reusable. So findable very broadly means that, all of the information, all relevant information should be in here for others to find it. For drone data, that typically means that, you typically map a certain drone area. So this area of interest should be in there because that's how people would look for data. And also it should include what is described in the data sets. And also, of course, when it was taken. Accessible, maybe the most important one, is that, the data is something, it should be accessible for everybody, for free, ideally. And also that kind of the metadata, which describes the data set, is a really important part of that, and that's also accessible. Interoperable means more or less that, tools can actually process this, that it can be automated, like you can put this data in different kind of portals and can access it, that people can, more or less write some kind of algorithm that finds this data. That basically comes down that when you describe your data set, you should use a vocabulary that is standardized. So you need to have follow some kind of standards that it can be found. And reusable means more or less in this context that, people can continue and use your data. That's clear to which degree people can use your data, which degree they need to, cite you and so on. And I don't know, very, very, very simply said is put yourself in the shoes of somebody who's looking for data of a certain area and who knows that there has been a drone mission before. Put yourself in the shoes of this person and try to give this person all of the information that this person would need to reuse the data. So fair data sharing basic concepts already been found in the Bible, more or less. Okay. So how this is being done? Because it's not a simple process, to be honest. And actually, it took us a couple of weeks and certainly several working days to figure this out. So it's not an obvious process. And I would, in particular, thank Ilkka. He's also from the SIOS-KC, who has been working with this on me together for quite intense time, and who made this happen. As well as some folks from the Arctic Data Center who are maybe listening in as well. So thanks for that. It's not a simple process. So I try to break it down in as high level and as easy to follow steps as possible. And I walk you through all of them. I'll also give you a very short kind of live demonstration of how fast this can go once you set up everything. My idea here is that for you guys, you will not need to spend as much time as we did to run these things, because you can just follow hopefully easy to implement protocol that we are describing here, and that we'll also make available to you. So after this event, we'll send around a couple of links that you can follow up on and do this yourself. So how does the overall workflow look like? So typically it should start with your data collection. So you go fly your drones, and what you get from that is typically some kind of raw images or videos, so JPEGs or PNGs. Then you do run some kind of data processing with your files. Typically this will be some kind of structure for motion photogrammetry method, where you generate your digital iteration models or 3D models or orthomosaics or whatever. And then you need to export this data. And Most commonly, people use GeoTIFF for this. There's also a couple of other formats. But GeoTIFF is kind of like the standard because it includes, your elevation data for digital elevation model or your RGB data if it's a picture, as well as the coordinates for it. So typically GeoTIFF data is what most people use and exchange. However, for FAIR data sharing, GeoTIFF is not ideal. So what we'll need to do is we'll need to transform this into NetCDF format. And I'll describe, of course, how this goes. And once you have that, then you need to describe the metadata. This can be done in like very simple, like CSV file. It's kind of an Excel file. And then you need to combine these two, the metadata with your NetCDF data. And then you submit it, and then you're done. So this seems pretty wild and a little bit complicated, but I'll walk you through it step by step. So let's start up with the first part, like the data collection, data processing, data exporting. We all got this, right? Like this is what we do. Hopefully you know what to do. If not, there are some other webinars on how to develop drone data. This is not about that. I expect that you start out with like a Argisoft project or forgot the other tools, but there's a bunch of tools that can generate the DEMs and that you are able to export it in GeoTIFF format. If you can, depending what you use, you may also be able to export it into NetCDF format directly. However, mostly that's not possible. Most tools don't know NetCDF, so you need to export it into or translate it or transform it into NetCDF from GeoTIFF. And you can also transform it into NetCDF from a bunch of other formats. But this should be the most common one. So what is NetCDF? It's the Network Common Data Form. So it's a data format specifically designed for storing and managing multidimensional scientific data. It's widely used in fields such as climate research, oceanography, meteorology, remote sensing, where you have got large volumes of data that need to be stored and analyzed efficiently. All right. So what does this really mean? It means it's a file format that can include data and metadata at the same time. So typically your results, it's something that is, if it's a digital elevation model, it includes some elevation data and some coordinate data. But the advantage of this NetCDF data is really that you can add more layers to this. And one layer in particular is that you can have the metadata that describes the data set in the same file. So in the end, all that you need to hand around is like one file that includes all the information you need and the data itself. So that makes it very easy to share and kind of, removes this kind of risk that there's data floating around that nobody knows where it comes from or what it really means. It should be all described in one thing. I will not go into like how this is built up, but this is actually not kind of the way that the data is stored in here is not very different from a GeoTIFF. You can have like a lot of different variables with a lot of like indexes and like information. So for us, mostly what it means, you can have in there the coordinates and you can have in there your elevation data if it's a digital elevation model or your RGB data if it's a picture. And in addition to this, you can have this metadata. The metadata is clearly labeled as such, so it's not affected by the operations. And you can open NetCDF data with most tools that you use. So if you use QGIS or if you use ArcGIS, they can open NetCDF and they will be able to process it in the same way as it would if you would be using GeoTIFF. So how do we do these kind of translations? Well, we have to become hackermans ourselves. Unfortunately, there's no really good tools that make it like super easy or like web-based or something like that. So we'll have to use Python. And this is, I know for some people, a pretty big barrier. I'll admit for myself as well, like I know scientific coding, but honestly, I work with MATLAB and I don't work a lot with Python. So it took me a couple of days really to get really into this on what I'm supposed to do and how to do this. The lucky thing is I wrote all of it down, and that's going to be part of the protocol to describe on what you really need to do. It's not a lot of programming you need to do, I promise. For those of you who are a little bit more familiar with Python, essentially what we'll be using is a GDAL package, which is a package that is used to deal with different forms of remote sensing data. and will not be using anything particular. It's really just one single line of code that you need to use, which is this one. We basically just need to tell this package GDAL to translate the GeoTIFF into the netCDF. So you just have to use this line, use the input line and the output file, and that's pretty much it. All right. So if we do this, then we have now transformed our raw data, or sorry, not the raw data, but our GeoTIFF processed, let's say it's a DEM, into the netCDF format. That's all it takes. It might take a couple of minutes or hours if it's a very big data set. So then the next thing that we need to do is we need to describe the metadata. And this is really something where you have to spend a lot of time, and it's probably quite annoying because you probably already described a lot of it in the publication. But it also means that all the information is typically available somewhere, but you have to really sit down, and this feels very much like homework. Like you have to add in, like, when did you go out to collect the data? Where did you collect the data? You need to find like the coordinates, ideally of like kind of the bounding box of where your data was collected. You should describe how you collected the data. You should describe what platforms you have used. There's a bunch of information that needs to go in there. And as mentioned before, we kind of want to include here also standard vocabulary. And luckily, we don't have to come up with this ourselves. This is something that people who've been dealing with these issues came up with and agreed on. So there is certain conventions that we can just like follow. Essentially, it means that you're using a standard set of vocabulary. For example, if you want to describe which field this is, like you talk about glaciers, great. There's a standard set of vocabulary that you can follow up that describes that your keyword is glaciers. And that will make it for other people, if they want to kind of filter for your results, just easier to make sure that you find glaciers. And because there's a lot of words and things there's like different vocabularies out there, there's a very standardized way. You can look this up online and it's pretty self-explaining, to be honest. Again, I should have added a link here. I haven't done so, but I'll do that. So in the very end of how this looks like is it's going to be some kind of an Excel form for which you get, of course, a template that you just need to fill in. So information like the title or a long summary of what it is. Then keywords, that's this standardized vocabulary that I've just described about. So the example data set, it's about a Pingo. So the keywords, for example, would be Earth Science, Cryosphere, Frozen Ground, Active Layer. So that's the first keyword. Then the second keyword is Earth Science, Solid Earth, Geomorphic Landforms, Fluvial Landforms, and Pingo. And this is kind of the standard data sets that you get from, you can basically get from the website. Then you want to give some information of what is kind of where this data was taken from. So you need to give some coordinates. You need to give some time coverages on when this data set was collected. So typically when you flew your drone missions, and a bunch of other information of like who made this, how can they contact you, was this linked to any other projects, what platforms, what drone platforms have you been using, what sensor, so what instrument, what sensor, so which camera was on the platform, and so on and so on. This takes a little bit of a while, but once you've done this, it will go very, very fast the next times because a lot of the information don't really change. So now that you've prepared this metadata in this kind of Excel file or .csv file, then you need to combine it. So first what we did is we started out with the GeoTIFF, and then we used this GDAL package to transform it to netCDF. So that's the new data. And now we have this metadata, and we want to combine this into the netCDF with metadata. All right. It's my favorite meme of this presentation, but you take the drone data, you take the metadata, you combine it, and you get FAIR data. Great. So once you have this FAIR data, and how you do this, there's also a Python program that we wrote that you can just use. You just need to run it, and it's going to be very, very simple to do. And I'll show you how exactly to do it. And once you have done this, congratulations, you have your FAIR data set, and now you need to submit it somewhere. I'm not going to go too much into that, but there is a lot of different sources where you can share these. Some are better, some are worse. You can use, of course, Zenodo. If you want it to be included in the SIOS data portal, there is a subset of providers that are truly fair. Arctic Data Center is one of them. where you can submit this, and they will also have some information providers and kind of methods on how to do this. I will not go too much into that. If you're more interested about this, there is actually a lot of information on the websites, and or as you heard from Ash in the Polar Night Week, there's going to be more information on how to do that. This is something that a lot of people deal with, so this is very well described. On how to deal with the drone data, that's really the special part that I wanted to talk more about. So one link here is actually on SIOS. There's much more information about data submission. Good. So going forward, what I want to do is I want to really show you on how this is actually done in reality. And basically, the starting point for this will be to look into a GitHub. A GitHub, if you've never used GitHub before, is just sort of a website where you can upload your code and that other people can download. So let me see, and I must admit that. So let me see. So this is the GitHub, and I must admit this might change in the next couple of days because I need to talk with Ilkka, who has started this this GitHub. If actually he should be the person to maintain it, or if it should be maybe me, it doesn't really matter. This is the GitHub, and it'll look something very similar like this, and you get a link to it. If you've never seen this, it's basically just a way to make sure that when people download your code or some code base or some help to run some things, they always upload the latest version. So you can always, kind of, it's kind of a fair way of sharing software code, actually. Anyway, so what you do is like, once you see this, once you get this link, you actually just like download everything in a zip file. That's all you need. And if you do, you go to your computer and then you unpack it somewhere. I've done that here in this test folder. So here was a zip file and I unpacked it. And it's going to look something like this. The key thing here will be that there will be a data. You will need to add some data into this. And actually, I should be able to remove everything. And this is what you will find when you should download this. You'll find an example data set, which is this lagoon pingo that I talked about. So it's a TIFF, it's a GeoTIFF. Let me see, we should be actually able to open this. Yes, we are. So this is some drone mapping that we did. Can't exactly remember what we see here, but this is, I think, the pingo, the lagoon pingo across the bay from Advent down on the other side. There's some interesting processes going on. I don't really care. I just created DMs, so that's what it is. And then there is this CSV file, which as I mentioned before, is kind of this Excel file. And all the key information will be filled in here. And then you just need to go in and you need to fill in your own information. And there's also going to be in the protocol some more information on what each of these fields really mean. They're more or less self-explanatory, right? Time coverage, the conventions, then history, and so on and so on. Okay, so once we have downloaded all of this data, then we need to go into this hackerman mode, and we need some kind of method to be able to run Python. So there's a lot of different tools for that. I recommend, or the people who know more about this recommended Anaconda to me. So I'm like, okay, great. I'll just do that. So there's also going to be some information on how to install that. And essentially, there is going to be one file that you will need to edit. And you can use a normal editor, or you can use a dedicated kind of code editor to look at this. And this might look a little bit intimidating, but I promise you it's very, very simple. So this is a script, an algorithm, and all that you need to look at here is the last line. This is very typical, that you need to just specify some file names and locations. So in this case, you need to input the location of the raw file, the starting file. So that's the GeoTIFF file that I mentioned before. And then you need to specify an output file for the converted netcdf file. You need to provide a location of the metadata, and then you need to provide a location for the output data. All right. So That's the only thing that you need to change here. So once you've adapted, and that's of course also described in the README file of this file. And once you've done that, all you need to really do is run Python, run this Python script, which is going to look like this. And I'm so sure that I'm so sure this is not going to work for some reason when I'm trying to show it. No, it does. And actually, the way that we programmed it, that is actually going to ask you if you want to do this GDAL transformation here. So you can just like say, do you want to skip it? No, I don't want to skip it. So then everything gonna work hopefully perfectly. And of course, something blew up. Even though I kind of tested this before, but I have the feeling that I deleted something I shouldn't have deleted. Yes, I did. Because I had a different file name in here. So the only thing that I went wrong is that I changed something here. So I just need to change the file names, and then hopefully it will work. This is trying to do coding live is always the most stressful thing in the world. So it asked me again, do I want to skip this?
You forgot .csv at the end.
I did forget the .csv at the end. That's correct. Jesus Christ, whew, it all worked out. Thanks. I guess it was Luke noticing that one. Yes. So once you've done that, you see that you have a couple of new files in your data folder here. So now there's this .nc file, which is this netcdf file, and I think in the main folder here is this Pingo DEM with metadata, which is this new FAIR dataset that we wanted to look at. And this is then something that you can start submitting to whichever data repository you wanted to use. Okay, so trying to jump back into the presentation, just to give to summarize what we've done. So sharing data is key in today's research environments. I think there's a lot of good reasons for it. My main motivation of doing this is really, I want people to be able to use my data more than I am to. Like if I collect some data samples, how cool is that if somebody goes ahead and like uses my data to do their own research? And if I'm a little bit lucky, they might even cite me in their paper. So hey, that's pretty cool. And at the same, so it can actually be a way to increase your own impact. And at the same way, of course, you can increase, your own work. You can extend it. Like, how cool would it be if for the research side that you're studying, somebody else went out and did some drone work, and they, you find their data, and like it gives you new perspectives to your problem. So for drones data, this is especially valuable because it is so high resolution. You can see a lot of things in here and a lot more than you might think when you actually collect the data. So people might be able to use it for something else than you originally intended to. I think that's pretty cool. So what we did here now is we developed and documented the process on how to share Svalbard-based drone data in the SIOS data portal. It requires some coding skills, but really, really minimum coding skills. And the example can be downloaded from GitHub, and it also includes some more information about how to do some of the preparation steps and how to install Anaconda, how to find all of this standardized vocabulary. We will share the final GitHub link in a couple of days. I need to just hash this out with Ilkka first, but I promise that this will be there, and we'll also add it to this webinar in some form. And that's it actually from my side already, and I think I guess there's going to be a bunch of questions that hopefully I will be able to answer, or if not, then maybe some of the more experienced FAIR data people who I know are joining this event can help me out with. But yeah, thanks for your attention, and yeah, talk to you soon.